Hi everybody, this is Mr. Bradley from Ralston Valley High School, and I'm making this screencast to teach you how to convert units in the process of solving problems in physics. So first, let's just start a little bit talking about what the units are that we look at and why we'd need to convert them. So oftentimes you will be able to measure things in metric units, right? Like things like meters and seconds, and therefore you could use meters and seconds to find a speed in meters per second. And for that matter, you could find an acceleration in meters per second. But other times you might be measuring something in the English system, something like a distance in feet and a time in seconds, which means you could find a speed in feet per second, or you could find an acceleration in feet per second. In even other situations, you might have some other units of distance that are really just fractions or multiples of these metric and English units. Like centimeters and kilometers are really just different magnitudes of order of meters. Like there's 100 centimeters in a meter and there's 1,000 meters in a kilometer. Or you might have something like miles and inches, which are really, again, just multiples or fractions of a foot. There's 5,280 feet in a mile, and there's 12 inches in a foot. And if you had those units, you could calculate speeds and velocities in different units. But you also might have different time units as well. Like you might have time in minutes and hours instead of being in seconds. So there's lots of different units that quantities can be measured in. But the important thing is that to be able to relate different variables together, they have to be in agreeable units. And here's a very simple example for what I mean by that. Let's say that I went out and measured the distance, a distance on the football field, and I measured it in meters. And I measured, 35 meters on the football field. But somebody else went out and measured a different distance, in feet, and let's say that they measured that distance to be 35 feet. And then if I wanted to add the two distances together that we measured, I guess I could say it's 35 meters plus 35 feet, but I'd rather be able to just have one number that measured the whole distance. And so therefore I would need to convert one of these either from meters to feet or feet to meters, so then I could add them together, right? That's really the most logical way of thinking about this. But it also extends into much more complex calculations. If you want to be able to find a speed in meters per second, you can't use a distance in feet. You'd have to have a distance in meters. So if you were given a distance in feet, you have to convert it to meters first, so that then you can find a speed in meters per second, okay? So what I'm going to do is show you the process by which we would use to do that. So on the next slide, I have a little explanation basically saying the same thing that I just told you with a little bit different example. But through this example, what I really want to do is I want to change the distance of 12 kilometers to miles. I want to know essentially like how many miles is 12 kilometers. Of course, I could Google that and get an answer pretty quickly, but we want you to learn a method, like a mathematical method that you can use to do that conversion both quickly and accurately, okay? There's actually two different methods out there that you will see people use. One of them is called the factor label method. That's kind of the most common method that is used throughout the world. There's also a method called the monorail method, which is a little bit more chemistry specific. Truly, these two methods are the exact same thing. They just look a little different. So I'm going to do this example with both methods so you can see what they look like, okay? Now, before I do either one of those, the important thing is I have to have a conversion factor. I have to have some conversion factor that relates together the kilometers to the miles. And in this case, the conversion factor I'm going to use is that 1 mile is the same distance as 1.609 kilometers. You could probably find a different conversion factor online that tells you 1 kilometer is a certain number of miles, and you could use that conversion factor and with the exact same method that I'm going to show you. So it doesn't really matter which conversion factor you pick, but you need to have a conversion factor. So this is the one that I'm going to use for the process. So the first one I'm going to show you, I'm going to show you this first with the factor label method, just because that's like my preferred method of doing this, and that's also really the most common method that you see used throughout the world. So the way I start is simply like this. I'm going to convert 12 kilometers to miles. I'm writing that on the paper just so that I have a way to organize my thinking, and I can go back and look at, what am I really trying to do here? Now, the next step is write down 12 kilometers again. And then what I'm going to do is I'm going to multiply 12 kilometers by a fraction that represents my conversion factor that I have circled up here. Now, when I write this conversion factor in a fraction, I could put the 1.609 kilometers on top and the miles on the bottom, or I could put the miles on the top and the kilometers on the bottom. The way I'm going to decide how to write it is based on what I want to end up with. Since I want to end up with miles, I'm going to put miles on top. And therefore, then I will put kilometers on the bottom. Now, the other thing that happens here is by putting kilometers on the bottom of the fraction, that means it will cancel out the kilometers that I started with, right? It's like if I had a fraction over here and I went 1 over 4 times 4 over 2, right? The 4's cancel out, and this is really just like 1 over 2. It's the same idea. When something in the denominator can cancel out something in the numerator if they're the same thing. So this kilometers can cancel out that kilometers. Now all I do is fill in the values that go with the appropriate unit. So 1 mile is 1.609 kilometers. What I'm going to do now is take 12 kilometers and I'm going to multiply it by the fraction 1 over 1.609. Essentially, I'm just going to take 12 divided by 1.609. So on my calculator, I'm going to take 1 divided by 1.609, and I get 0.6215. Oops, sorry, I didn't mean to say 1. I meant to say 12 divided by 1.609, and I get 7.458. And that is miles. So 12 kilometers is 7.458 miles. I need to apply the rules of significant figures here, right? And the way I do that is I basically say, if I only had 2 sig figs here, I can only have 2 sig figs here. So I'm going to round my answer to have 2 sig figs. So this is going to be 7.5 miles. What I basically just did is I converted the distance of 12 kilometers into the same distance, but just in miles. I'm just telling you different ways to express the same distance. That's what I did here, okay? All right, so now let me show you that exact same conversion just using the monorail method, okay? So the way the monorail method works is like this. Instead of thinking about fractions, you create this monorail. A monorail is basically a single horizontal line that could have multiple vertical lines. In this case, I only need 1 vertical line. In the top left-hand corner of my monorail, I'm going to put the 12 kilometers. On this part of the monorail is where I'm going to put my conversion factor. And I'm going to choose to put the numbers in the same place I did before because I still want to end up with miles on top, and I want to cancel out the kilometers that I had. And so, again, I'm going to go 1 mile is 1.609 kilometers. And now I essentially would just say I'm going to multiply everything together that's on the top of my monorail, and I'm going to divide by anything that's on the bottom of my monorail, and essentially I still just do the same math. I'm going to take 12 divided by 1.609, and I'm going to get, when I round it, 7.5 miles. Okay? I mean, the monorail method and the factor label method are the same thing, right? I mean, I'm doing the exact same math. They just visually have a little bit different look about them. When you want to convert units, you're allowed to use whichever method you want, but just make sure you're showing your work and make sure it's understandable to whoever it is that might be looking at it. Okay? okay? All right, so let's take a quick check for understanding here to make sure you understand how this works. So a person wants to know how far they can drive in 25 minutes if they maintain a speed of 65 miles per hour. The units of minutes and miles per hour don't have matching time units. They don't agree. So a unit conversion would have to be done before calculating the distance. Which answer is the best example of the unit conversion that should be done? I'm going to allow the video to pause for a little bit so you can think through the answers. Okay, so the correct answer here is letter A, right? Letter A is the correct answer. This is the monorail method of converting minutes to hours. I used a conversion factor that basically says 1 hour is 60 minutes, and I put 60 minutes on the bottom so that the minutes would cancel out, and I put hours on top so that my answer would be in hours. This is the correct method and also the correct way of showing it. This is the right math, but it doesn't communicate what was done, and so this would not receive full credit. Okay, this is the factor label method, but the conversion factor is mixed up, right? There's not 60 hours in 1 minute. This got mixed up, and hopefully, if you got this answer, you would question yourself because 25 minutes is not 1,500 hours. Okay, and then again, this is like not only the wrong math, but it's also the wrong procedure and process, and so everything's wrong here about letter D. Okay, all right. So now what I want to do is do a little bit more discussion of this, but just thinking about the metric system for a quick second. So sometimes we just need to do metric conversions, right? Like we need to say how do I express 16.3 kilometers in meters, right? And some of you know ways of doing that by moving the decimal, or if you're supposed to multiply or divide by 1,000 or whatever, and that's good. But I want to show you what this would look like if I was going to use a conversion factor. So I again start off with 16.3 kilometers, and I want to get that in meters. I need to have a conversion factor between kilometers and meters. Well, that's what this is over here, okay? The metric prefix kilo means 10 to the third, or it means 1,000. So that means 1 kilometer is the same as 1,000 meters. 1 kilometer is 1,000 meters. That's my conversion factor. If I'm starting off with 16.3 kilometers, I'm going to multiply by a conversion factor that will allow me to have meters as my final answer, which means meters needs to be on the top and kilometers needs to be on the bottom. So I'm going to write my conversion factor in this fraction with 1,000 meters on top and 1 kilometer on the bottom. I'm going to take 16.3, I'm going to multiply by 1,000, and I'm going to divide by 1. That ends up being 16,300 meters. Okay? That's a simple way that you can use a unit conversion process to convert in metric units. There's other ways to do it too, and we'll just be discussing many of those in class. Okay? All right, I'm not going to do this example in the interest of time, but I am going to talk about this example because sometimes you have to do multiple conversions, right? Sometimes you have to have a multiple step conversion. For instance, I want to know how far is 1.5 furlongs in meters. A furlong is like a kind of an older distance unit that was used to measure distances in horse racing, okay? I could probably look up online like how many meters are in a furlong and I could have a single conversion. But since I have these conversion factors over here, I'm going to rely upon those conversion factors to do a multiple step conversion, okay? So using the factor label method, it looks like this. 1.5 furlongs times the conversion factor between furlongs and yards, okay? I want to cancel out furlongs, and I want to have yards on top. And so 220 yards is 1 furlong. If I did that math, I would have a distance in yards now. But yards is not meters. I got to keep going. So I'm going to multiply by a conversion factor that has yards on the bottom and feet on top because I have this conversion factor. 1 yard is 3 feet. Yards cancel, and if I did this math, I would have a distance in feet. I'm not quite there yet. I got to do one more conversion with my conversion factor between feet and meters. I'm going to put feet on the bottom. I'm going to put meters on top. 1 foot is 0.3048 meters. Now, all the kind of in-between units have canceled, and I've gone from furlongs to meters, which is what my ultimate goal was. So I'm going to take 1.5 times 220 times 3 times 0.3048. And the reason I'm doing that is because all of these conversion factor numbers are on the top. So I just multiply by everything on the top. So when I take 1.5 times 220 times 3 times 0.3048, I get 301.752. So this one's kind of a weird one in terms of rounding for sig figs. I'm not going to follow the proper sig fig rules right here because I don't want to make it super complicated, and I'm just going to round this to 302 meters. 1.5 furlongs is basically 302 meters. It's the same distance, just expressed with different unit systems. Okay? All right, one more example to do. And this example is really where you're going to find yourself doing it most often in physics. And this is where you're going to convert speed units, okay? Oftentimes you'll get a speed that's in miles per hour and you need to convert it to meters per second. Or other way around, you'll get a speed that's in meters per second and you got to convert it to miles per hour. That takes like 2 steps because you're going to have to convert the distance unit either from miles to meters or backwards, and you're going to have to convert the time unit, right? So this is one of those conversions that we do a lot of, and you should kind of look at this one and hopefully get pretty comfortable with doing it. So what I have here when I read this problem is this. Noah Lyles, who was an Olympic sprinter, a few years ago, ran 100 meters dash with an average speed of 10.2 meters per second. By the way, that's really fast, right? If I told you that I could run 10.2 meters per second, you would probably doubt that because you know I'm not an Olympic sprinter, but you also might just wonder, like, how fast is that really? That's why we want to convert the units, is so we can really see how fast that is in something that we are familiar with, okay? So here's how I'm going to set this up with the factor label method. When I write the speed that I'm trying to convert, I'm going to write it 10.2 meters over seconds. It's really the same thing as saying I would run 10.2 meters in 1 second. I'm really writing the unit of the speed as a direct fraction instead of like this, which is easier to type, okay? And I'm going to multiply by 2 conversion factors. I'm going to multiply by 1 conversion factor that will change the meters to miles. And I'm going to multiply by another conversion factor that will change the seconds to hours. Now, the reason I'm choosing to put these letters where I put them is because I'm trying to cancel out the unit that I previously had, and so I have to put that same unit opposite in the fraction so that they will cancel. Because I want to get rid of the seconds, which is in the denominator, it needs to be in the numerator of my conversion factor. Now when I do this math, I'll have miles on top, I'll have hours on the bottom, I'll have speed in miles per hour. Now I just fill in the units, the conversion factors where they go in the appropriate place. So 1 mile is 1,609 meters. 1 hour is 3,600 seconds. Hey, if you're wondering where that came from, 1 hour equals 60 minutes. 1 minute is 60 seconds. 60 times 60 is 3,600. This is one that you're just going to memorize, frankly. Okay, so now that I have my unit conversion set up properly, I'm basically going to multiply everything that's on top, and I'm going to divide by everything that's on the bottom. Or you could go 10.2 divided by 1609, multiplied by 3600. You can do it whatever order you want. Just realize anything that's on top gets multiplied, and you divide by anything on the bottom. So I'm going to go 10.2 divided by 1609 multiplied by 3600, and I get 22.82. That's going to round appropriately to 22.8 miles per hour. If you know somebody that tells you that they can run 22 miles per hour, they're running really fast. I encourage you to try that sometime. It's very, very fast, okay? So that is how you convert speeds, right? Converting speeds typically requires 2 steps in the conversion because you usually have to convert the distance unit from the distance you were given to a different distance, and the time unit to the time you were given to a different time. Okay, if you need some more help, then I have 2 recommendations for you. First, you could look in the physics soft text, right? If you take physics at Ralston Valley High School, we have a section in our book that's about this, and it starts on page 12 of the physics soft text, okay? That is my first recommendation for you. My second recommendation is just, go to YouTube and type in converting units, and you are going to find lots and lots of different videos out there that basically show you the same process that I showed you. The more practice and the more exposure you get with this, the better you're going to get, okay? All right, so we're going to assign you some problems now so that you can practice this. Good luck, and we will review these on another day in the future in class. Thanks.